Here's the graph of f of x, and we want to sketch the graph of y plus 4 equals f of 1/2 x plus 1. For me personally, I would start by rewriting this with everything on one side. I like that better. I noticed, oh, really exaggerate this. Sometimes I like, when I have brackets inside of brackets, for my brain, it really helps if I make them different sizes. So my outside brackets I made really big, exaggerated, my inside brackets really small. I moved the 4 over to the other side. Notice this is already in factored form. Things are good. The 1/2 has been factored out. So when we go from left to right to label things, this is going to be a horizontal stretch. This is going to be a horizontal translation, and this is going to be a vertical translation. For me personally, I'm going to, I know they took the fraction point. Don't you think this point is nicer? The 1, 1, and the -1. I'm going to use those points. 1, 1, and -1, -1. I'm also going to add in here, they didn't draw them in, and I'm also going to add both of my asymptotes. Both my asymptotes to my transformations as well.
The two red things are just one graph.
What's that?
The two red things are just one graph.
The two red things are just one graph, yes. And we're going to look at the actual equation of this in explicit notation as well. It's always, I think, at the beginning, easier in function notation. Because it was really easy to see what was inside in function notation, really easy to see what's outside. When we draw our arrows, we'll just do the points first. We do all of our stretches and compressions first. You see you only have one stretch. What is that stretch going to do? It's going to multiply your x by 2. We have two translations. The +1 x's are liars. That's going to go 1 to the left. The -4 is vertical. That's going to go 4 down. Are you okay? L for left? You're okay with D for down? And now it's just simple mental math, which is the easy part where you really just have to pay attention that you don't do the wrong coordinate. I'm doing my x values by 2. Then 1 left will be 1, 1 left will be -3, 4 down, -3, 4 down, -5. Next, what's going to happen to your asymptotes? Now, when your asymptote is at 0, does it make sense that any stretch, compression, or reflection does not change it? Because you're multiplying, and it's already at 0. So here x, the x1, which is at 0, gets multiplied by 2. Well, it's still going to be 0. So here, I'm just going to draw a long arrow and say, where does it end up? The only thing that's going to affect it is left, right, up, and down. It was at x equals 0. It went 1 to the left. So it will be at x equals -1. It was at y equals 0. It went 4 down. It's now going to be at -4. I'm going to not sketch on the same graph. I find that graphs with asymptotes, if you start sketching them on the same graph, it just gets to be too busy. So it's a little bit easier just to say, you know what? I'm going to start a new graph on this new graph. I'm going to add my vertical asymptote is now at x equals -1, and my horizontal asymptote is now at y equals -4. I can plot my new points in 1, -3, and -3, -5, and just draw towards my asymptotes. And our graph is done. Technically, I wouldn't have to label these points because I wouldn't lose an E9 error because my asymptotes provide the scale. That being said, I think it is not bad to label the points anyways. Does anyone recognize the original graph from our colored papers? It's the 1 over x. So I am going to write the explicit equation and see if you think you could have graphed the explicit equation. So the explicit equation, we're saying that the original graph, f of x, was 1 over x. The blue graph that we just graphed there was y equals, in function notation, f of, let's go back up, right? 1/2, oh yeah, it's big bracket. X plus 1 minus 4. So again, can we practice changing between function notation and explicit notation? So the way that function notation works, wherever you have f of x, that gets replaced with 1 over x. Whatever you have inside your function replaces what the x has. And whatever's outside stays outside. So here's my f, and it's got a whole bunch of stuff inside. So that part will become y equals 1 over 1/2 x plus 1. And then afterwards, I have a minus 4. And you will get questions that ask you to graph this as well. If I gave you that equation first, I think it's a little bit more complicated. It's a little bit more complicated. One, you have to recognize that this is related to 1 over x. Then you have to recognize that this 1/2 is where the x is, so that's your horizontal stretch. This 1 is where the x is, that's a horizontal translation. This 4 is outside, is a vertical translation. So we can ask the same question with explicit notation or function notation. Right now the function notation is a little bit easier. One thing that's nice about the function notation is they also have to give you the graph, so that saves you a step. You didn't have to remember what the 1 over x graph looked like. Okay, well, I've been hoping for years to get an endorsement. The questions for practice are 7-11, but as of yet, I've gotten no free Slurpees whatsoever. Every time I do this question, I plug 7-11. And I haven't gotten any advertisement royalties yet.